So welcome back to this tutorial, and today we're going to talk about managing basic storage, and this is based on storage devices or in relation to storage devices as far as Linux operating system is concerned. Now remember, this is a RH135, which is actually Red Hat Administration 2, and yeah, talking about managing basic storage, what is our goal or what is the ultimate goal when it comes to understanding this particular topic? So we need to understand how do we create and manage storage devices? How do we perform partitions, or how do we create and again manage partitions? How do we create and manage file systems? And again, how do we create and manage subspaces from the command line? So all this is all about creating and the management of storage devices, storage devices, partitions, file systems, and subspaces from the command line. Now, the objectives of this particular unit is all about the same details, that is, how to create storage partitions, how to format them with a file system, and again, how to mount them for use. And again, how do we create and manage swap spaces to supplement physical memory? So here we are talking about the partitioning or managing or creating and managing storage devices such as the hard disk. So remember that in the operating system or in Linux operating system or whether it's any other operating system, you have to allocate some disk space for it to operate. Now, here we have around 3 sections. The first section is all about adding partitions, file systems, and persistent mount, that is mounting permanently. And then again, we can also talk about managing swap space. So we will start from a more basic level about adding partitions. And in this case, remember that we're using what? We are actually using the Red Hat 8, which is actually like the latest Red Hat operating system. So let me just open my terminal so that we can get to know about these concepts. Now I'm going to open, let's say, my notepad, and here we go. So here we will talk about what? So the first point is about adding partitions, file systems, and perform something called the persistent mounts. So that is number one. So in this case, the objective is all about what? Creating storage partitions, understanding how to format them, and again, how to, and especially when it comes to formatting a specific storage device or a storage partition, we need to format them with the file system and again, mount them, because you cannot actually use it as it is, only formatted with the file system. You have to mount it so say that it is available for use. So in this case, we will start by probably defining what is partitioning or partitioning a disk. Partitioning or partitioning a disk. So in other words, you can talk about disk partitioning. Now, disk partitioning here allows, allows system administrators, it says allow system administrators to divide a hard drive, into multiple logical storage unit. And these units are referred to as what? So they're referred to as partitions. To add partitions. So in this case, we are talking about what? We have, first of all, the hard drive or the hard disk. So when the hard disk is actually subdivided into multiple logical storage units, they're referred to as partitions. So disk partitioning is actually a process is actually a process. So in this case, we can actually also say that once we have these disks, by separating a disk into partitions, because of course, once we, as you perform partitions, is more like you're separating what? You're separating a disk into partitions. Now, so by so doing, it means that the system administrators can use different partitions to perform different functions. For example, disk partitioning is necessary or beneficial in the following scenarios. For example, number one, it's that once you have a partition, we have like it limit available space to applications or users. That is one beneficial in terms of performing disk partitioning. We also have like it separates the operating system and program files from user files. And then again, it creates a separate area for memory swapping. And then it limits disk space used to improve the performance of diagnostic tools and backup imaging. So those are more like the advantages or the benefits of disk partitioning or having partitions within the storage device. So it's not about like, we have a whole solid hard disk. If, for example, the hard disk is like 400, let's say, for example, we have a hard disk, which is let's say 1 terabyte. So, okay, let me give you this. So assume that we have 1000 GB. This is your disk. So it's actually a whole disk. Now, if I make, let's say, come up with a partition or partitions of 300 GB, 300 GB, 300 GB, and then I have, let's say, 100 GB. Now, it means that in this particular hard disk, whose capacity is 1000 GB or 1 terabyte, it means that we have 300 GB, 300 GB, 300 GB, 300 GB as what? As partitions. It's actually the subdivision. It's the subdivision of what? Of the 1000 GB. So this is exactly what we refer as partitions. So the process of creating these partitions is actually disk partitioning or partitioning a disk. Now, when it comes to the types of partitions, we have number one, we have something called MBR, or in other words, MBR, in other words, you can call it master boot record partitioning scheme. That is one type. And then we also have another one, which is called GPT. GPT partitioning, or in other words, you can call it, because we have, it's more like an initial, and this one you can call it GUID partition, let's say GID partition, yeah, so we can have partition table. What? Partition, partitioning, partitioning scheme. Yeah, so these are two types of what? Partitions. Now, when it comes to, when we talk about the MBR or the master boot record type of partitioning, what is the differences between using the GPT or MBR, or what optionalities can be there for you to choose between the two? So when you talk about MBR, it means that the number of partitions is actually dictated on which type of partition to use. So if you want, let's say, a type of partition that gives you, let's say, lesser number of primary partitions, then you can work with either the MBR or the GPT. But of course, we know that the MBR. So we have a limitation on which one to use. And again, how far it can go. So when you talk about MBR, we can say that this supports a maximum. This supports a maximum of 4 that is into bracket 4 primary partitions. So it means that if you need, it can actually support up to a maximum of 4 primary partitions. But on the other hand, it can actually go beyond that, because now apart from the primary partitions, we also have what? The extended partitions. So the continuation, and it can support, or it supports something called the extended and logical partitions. Logical partitions up to a maximum of 15 partitions. So in this case, it means that for the primary partitions that is being supported by MBR, it's actually 4 primary partitions. But when it comes now to, let's say, the extended and the logical partitions, it can go as far as 15 partitions. Now, when it comes to now the GPT, now this means what? As long as it's actually like a standard, for laying out partition tables, because of course it's a partition scheme, this one supports. So we can say it supports a maximum of 128 partitions. 128 partitions. And unlike an MBR, which uses actually the 2 bits for storing logical block addresses and size information, GPT allocates something called, the 64 bits for logical block addresses. So that also gives you the differences between the two. But from the way these partitions are created, you can judge between the two that which one gives you, let's say, more options of creating multiple partitions compared to the other. So for the MBR, it supports up to 4 primary partitions. And if you want to go beyond that, then you have to create something called the extended or the logical partitions, which goes up to a maximum of 15 partitions. But for the GUID, it actually supports up to a maximum of 128 partitions. Now, how do we manage partitions? So here we can talk about management of partitions. So when it comes to managing partitions, in this case, we have a command, because for Linux or if you want to manage anything in Linux operating system, we must have a command. And the command in this case is actually called the parted. Remember, in Red Hat 8, we have like new names for the commands. But even if you go to Red Hat or the earlier versions, you can also find a management command, or a command used to do what? To partition. So in Red Hat 8, we can call it what? Parted. But again, if you go to Red Hat 7 and also in Red Hat 8, we also have what? fdisk. So let's work with the parted, because it's actually it's actually attached to Red Hat 8. Now, when it comes to managing partitions with parted, for this case, it means that partition editors, which are actually like the system administrators, are programs or they are platforms which allow administrators to make changes to a disk partition. So we have the partition editor, where you can open or use the parted command, and it opens other options for system administrators to be allowed to do what? To perform more activities in relation to what? Partitions. So these activities or these changes that are made to a disk partition can be creating partitions, deleting partitions, changing partition types, and so many other activities. Now, to perform these operations, administrators can use the parted partition editor for both the MBR and the GPT partitioning scheme. So the partitions editor is open to both schemes or both partitioning schemes, whether you've chosen to work with MBR whether you've chosen to work with the GPT, you have the option. You have the option in that. Now, the parted command itself takes the device name of the whole disk as the first argument and one or more subcommands. Now, the following example, for example, if I can give you, let me just quit this part so that we can use. So let me quit. I don't want to save. Now, in this case, first of all, let me switch to a root or the super user. So we have this command which is called parted. And in this case, first of all, you have to know what? You have to know the way your blocks or the way your disks are partitioned, especially their disk. So first of all, I need to check by using lsblk. That means I'm listing the block. Now, look at my my disk. Now, if you remember, let's say ls root. If you remember the root system or the Linux file system, we have this particular folder, which is actually called dev. So for this particular dev folder or this particular directory, this is a directory that stores all the devices. For example, I can give it as dev, or I can give it as dev. Okay, so I will have dev. Now you can see that in dev, we have a lot of what? A lot of disks names, and we have a lot of info again. So when I come to lsblk, so that you can see, lsblk is just a single command. You can see that we have this particular disk, NVMe0N1, and you can see in dev we have what? We have this particular disk. Now this means what? This disk is of size what? 20 GB. So because I'm using a virtual machine, I've just allocated 20 GB for what? For my Linux operating system. Because remember, I have the operating system or another operating system on top of an operating system. So if I can show you probably how it is, you can see that this one is actually on top of another operating system. So it's actually on top of something called the virtual machine. So it means that I have allocated 20 GB of the original or the entire hard disk. So if my hard disk is 1000 terabyte, or I mean 1000 GB or 1 terabyte, I've actually only used 20 GB for my own Linux operating system. Now, because that is the total size for my disk, now I have created the partitions. And you can see that out of NVMe0N1, I have a partition 1. So up to this point, this is actually the actual name for my device. But here we have partition 1, we have partition 2, and we have partition 3. Now these are partitions, and each partition a space must be allocated to that. For P1, you see the whole disk is 20 GB. For partition 1, it carries what? 300 MB. For partition 2, it takes 2 GB. And then for the third, it takes 17.7 GB. So if you had 17.7 GB plus 2 GB, it becomes 19.7 GB, and then plus 300 MB, then it becomes probably that 19.7 and then plus the MBs. Now that is remaining like few, like a small size to reach what? To cover the entire 20 GB. Now, with this part, it means that my original hard disk is already there. Now, what happens is when we have now, or when we want to manage these partitions, because of lsblk, if I want to create that partition, I need to create from what? I need to create from the original disk, because I cannot actually get an allocation to this. Okay, for this one, we have 17.7 GB. So we will see whether we can create another partition out of another partition. So we normally use the word command, parted, and then we have dev, and then NVMe0N1. So in this case, it means what? If I want to print the subcommand or to display the partition table on the /dev/nvme 0 and 1, I need to do what? I need to do this. So if I want to extend that, I can use what? Print. So if I press enter, you can now see that this is my command. This is my command. So for me now to have it, you can see that the disk, the total is what? 21.5 GB. The sector size is actually the logical physical, which already we have that. And then this one is the partition table, which is actually MS-DOS. Now you can see even the way it is lined up. Now it's starting from 1049. It ends at 316 MB. The size is 315 MB. That is partition 1. The partition type is primary. The file system is XFS. We also have the second partition, this is primary. The file system is Linux swap. That is actually primary, and we have what? XFS. So here it means that I have successfully displayed the partition table based on /dev/nvme 0 and 1. So for that NVMe 0 and 1, this can be my own name, but on your side, you can also have a different name. So here it means that if, for example, you do not want to provide, let me just show you once more. You see, for example, the first command is I had to put parted and then followed by the device name. So this is the device name. I'm only giving the location, the exact location of my device name. Then print. What happens if I get rid of print? You see, I'm given what? Welcome to GNU parted. Type L to view a list of commands. But if I don't want, I can just type print and press enter. I can get the same what? The same concept. I can type L and press enter. You can see that I'm getting a lot of what? A lot of info when I press what? L. So it's actually referred to as the partition editor. It's actually referred to as the partition editor. Now, so in this case, it means that if you're to execute, let's have again that, and then I can type L, I can type print, but if I want to get out, I can just type exit, or I can just press Ctrl Z, and I'm out of that session. Now, in this case again, what happens if I want to writing the partition table on a new disk? Writing the partition table on a new disk. So for my case, it means that I have some limitation because my fixed size or the size of my disk space allocated to Linux operating system is around 20 GB. So we will see whether we are able to create a different what? A different operating system. Now, there was something here about, of course, let me just bring it again. Now, look at this. We have the partition table, which is what you call what? MS-DOS. The partition table is MS-DOS. Now, it's all about what? Relabeling. If I want to change MS-DOS now, because MS-DOS is attached to MBR partitioning scheme, if I want to change it to something different or to write a GPT disk label, I need to use a different functions. Now, let's see. I can use the word parted, and then let's say dev / I can have NVM N0 N, of course, NVMe N1, and then I can say MK label. Then I can have something like GPT. So it means that warning partitions on dev NVM are being used. So in this case, I will just do what? I will just ignore. So it's being used because the operating system already, it's being handled with the GPT partitioning, with the MBR partitioning scheme. So in this case, I have the inability now to go through. But if you want to change it to GPT, you can change using that. That is a parted, and then the name of the disk, which is actually within the dev, then MK label, which is actually make label, then GPT. If you want to make it to MS-DOS, you can only change it to MS-DOS and execute it. So for this case, I am unable to go to the other side of GPT because the operating system is already running on where? On that. So unless I have a different partition. Now, let's understand some concepts. How do we create MBR partitions? How do we come up with MBR partitions? So to create MBR partitions, first of all, I need to have, let's say, LSBLK. And let's see whether we can capture probably like 2 GB from partition 3, which is actually P3. Now, first of all, I need to display what? I need to display the entire, so parted, I now dev, and then I have NVMe N1, and then P3. So I'm going directly to what? To P3. And then for this case, I'll just press enter. It will tell me what? GNU parted 3.2 using /dev/NVMe 0 NP3. So this one is what? This one is partition 3. So welcome to GNU parted. And now, so the next step after this, because I want to create a partition out of the P3, let's say we want to get 2 GB out of 17.7 GB. I will just use MK part. So for the MK part, it will give me an option now. If I press enter, you can see that it gives me an option that the file system type. What is the file system type? So here I will just type, let's say, primary. And then on that, I'll just press what? Enter. So we have like the invalid token for this case. And let me just, sorry, okay. So I have not actually issued anything. So in this case, if it gives me, okay, let me just start so that we can have a good picture. So I've actually started from parted. So it's actually the partition 3 that has what? That has 17.7 GB. Press enter. Then here I will just type part, MK part. Press enter. It will tell me that the file system type is ext2. So it means that ext2 is an example of file system. So I need to have what? A file system called XFS. And then press enter. Then it will ask me which starting point or the size to start with. What is the starting size or what is the start size? So here I can give 2048 and I need to give it like S, press enter. What would be the end game? Let's say I want a partition, let's assume like 1000 MB. Of course, that is what? This is actually like 1 GB. I'll just press enter and then it will tell me too many primary partitions. So it means that based on MBR, you are only allowed to create up to a maximum of what? Up to a maximum of 4 primary partitions. Now, let me just cancel it so that we can go the other way, because maximum of 4 primary partitions, but anything beyond that, we are allowed to create up to a maximum of 15 partitions as extended or logical partitions. Now, let's have a look, because it's actually, the process is actually the same. So MK part, this time around, let's have like ext2. Starting is 2048. Ending is 1000 MB. Too many primary partitions. Okay, let me reduce it to that. MK part. Let's say ext2. Let me say 2048. Let's say 500 MB. So can't have the end before the start. Oh, so we have Okay, there's a problem here. So let me just start again. So we have MK part. Let's have like, okay, let me just assume it. And then let's have 2048S. Let's have like 500 MB. Too many primary partitions. Too many primary partitions. So here it means that we need to get rid of or to delete a partition. And how do we get that? Let's say help. Let me type help. Okay, let me just do this. Control that, clear. Okay, let me go with the first one, MK part. Now, yeah, so we are using what? The whole disk now. So partition type, primary or extended. So when we are asked that, then we choose, we work with, let me assume that we're working with primary or extended because we have around, okay, let's go the primary way and see what happens. Enter. And then I will have XFS. I want us to see whether we are, we've actually taken a maximum of 4. And then let's have it like 500 MB. That is for the XFS. And then from there, we'll just press enter. You request a partition from 1049 KB to 500 MB. So sectors, so is this still accessible to you? Yes, enter. Now you can see that warning, the resulting partition is not properly aligned for best performance. So probably I can just type ignore and then parted. So let me save it. So here it means what? Because the size is so small, that's why we are being given what? We are given that, we are actually given these warnings. So you remember from 2048 to around 500 MB, it's actually so small. So in this case, I can decide to exit or quit. You can have it like quit. So now if I come up to LSBLK and press enter, you can now see that we've successfully managed to come up with what? With the fourth partition, which is actually a primary partition, which has 512B. So LSBLK. So we've managed to come up with the fourth one, which is actually primary P4. So we've actually successfully given what? 512B. But here we've not actually attached any file system to it. So here, if I want to do, let's say parted, and then we have dev nvm nvme n1, and then let's see print. Now you can see what? We have the fourth one. This is actually the newly created word. So the file system has not been attached so far. The file system has not been attached so far. So we have 3 processes. The first process is to do what? The first process is to create a partition. The second process is to attach the file system. And the third process is to mount such that it will be available for all. But with all this, we also have like the shortest route to go by. You can actually use this line like dev nvm n1. You can say MK part. You can have it as primary. You can have it as XFS. You can have it as, let's say, 2048S. And then you can have 500 MB. So you see, this one is actually the shortest route to go by, because our part was that we did execute this first, then followed by this, then followed by this, and then followed by this, and then followed by this, and finally we end up at 500 MB. So you can perform that operation with what? With this one line. You can operate with only one line. So this is what? This is the MBR way. So let me just confirm something here. NVM N1, and then you can say L. Of course, let's say M. Okay. So we have this. Okay. So let me just clear. Now that is what? That is creating MBR partitions. Now, how do we create GPT partitions? How do we create GPT permissions? So not permissions, but partitions. So first of all, we need to specify the disk device to create the partition on. So the same thing happens. We have to go to the parted. Then from there, we specify dev, we specify NV, EN, E, NVM, E, N1, and then we press enter. For this case to be again the same process, but then for this case can't create any more partitions. So here it means what? We need to get rid of the partitions we just created. So let's see, how do we go about? So first of all, I want to delete that. Dev NVMe N1, then it will give us this. I will just type print. So we need to see which partition. So we have this. So you can see that because it's an MBR partition, we have 4 primary partitions. Cannot go beyond that. So we have 1, 2, 3, and 4 primary partitions. Then here I will say RM4. You see, I am removing what? I am removing the 4th partition, which is actually 4 here. So I will press enter, and then it will tell me what? That. So for me to save now the changes, I'll just say parted and press that. So in that means that, and then of course I will quit. So this time round, if I come back to this point, parted, and then say print, now you can see that I've successfully managed to remove what? To remove the 4th partition. Now, let's go back and do, what? Do the GPT. So for GPTs, follows the same rule. I will suggest the mkpart, and then it will tell me what? Partition type. Is it primary or is it extended? So when it shows this, it means that I will just pass that and just press enter for the partition. So of course, it will, let me have like extended, press enter. It will give me 2048 S, and then end, probably I can give like 1000 MB. Then for this case, it will also give me the same one, the same process, the same process. Now, so when it comes to this, let me just cancel. There's something not comfortable here. So when it comes to parted /dev /NVMe N1. So because this is aligned to an MBR type of partition, as a root user, we already have the MBR in place. So it's not actually giving me the option of executing the GPT pathway. And you see, when it comes to GPT, the file system type that you can use to create a partition, it can be an XFS or it can be an XT4. So it means that this does not actually create the file system of the partition. It is only an indication of the partition type when it comes to that. So we do not have like a specific way to do that. And I think that is something probably that I'll show you probably in a different tutorial. But because this one is attached to the MBR type of partition, it follows also the same route. So on deleting the partitions, you have to use the RM. For example, if I have to remove this, if I have to remove, let's say, partition 1, I'll just say parted def nvm, and then there I will just say what? Print. So it will display what? It will display for me all the available partitions. So if I decide to get rid of number 1, number 2, and number 3, I will only do what? RM for remove, and then specify the number of the partition I want to get rid of, number 3. So if you press enter from here, then it will automatically be removed. So I don't want to remove that. That is how to delete what? A partition. Now, for this case, I want us to create, let me repeat the MBR way so that we can come now and create the file system. So what happens is I will just use parted def nvm n1. Now in this case, I will come and create a partition. This one is a extended. Let's have it as extended. Let's have it as primary partition because it's not yet what? Full. So the number of primary partitions has not reached 4. So this one means that it's the 4th one. So here I will just use XFS, and then I will start from, let's say, 2048 S, and then ends at 1000 MB. And then I will say yes, and then I will say ignore. Then I will put the word parted, and then I will quit. Now, so when it comes to that, and go back to LSBLK, now you can see we have what? We have the 4th partition, the 4th primary partition. Now to bring back that, let's have it in broader way, nvm e n1, and then print. Now you can see what? You can see that we have the 4th primary partition, which we've actually created, we've successfully created. The only thing that has not been attached to is actually the file system. The file system has not been attached to this. So how do we attach a file system now? So to attach a file system, we need to use what? So let me just clear. Yeah. So to attach a file system, I need to use something called MKFS, make file system. And then I specify which file system do I want. I need XFS. If I need ext4, I will also put it there. Make file system.ext4. So here we can just have XFS, and then followed by what? Def, followed by nvme n1, but you have to specify the partition. So P4. So here it means that if I press enter, it will give me all this information. It will give me all this information, can get size of data, subvolume. Okay, so it means that the value is so low. Okay, let me just try it one more time. This time around, I can just use ext4. Okay, device size reported to be 0. Invalid partition specified for that. So this is how, if I had a very huge or bigger space, let's say 1 GB, 2 GB, 3 GB, then I think it could be possible for us to use it. Now let's go one way. Let's go like, let me repeat something, or let's just delete it. Okay, get rid of it and then create it again. Let me remove 4, and then parted for saving, and then quit. Let's be okay. You can see we've successfully managed to remove number 4. So I want to create it. I want to create another partition. So I will just say mkpart, let's say primary. Let me have it as XFS. Let's have is 2048S, that is the starting. And then let's have like 3000 MB. And then let me have it as yes. And then let's say ignore. And then you can have it as started. And then you can have as quit. Now, if I come to this, okay, let me just clear. I can come back to this is printing. Now you can see that we have the fourth one, which is 1049, size is 512B. I think the size is a little bit smaller, but now let's see how we can. So I come MKFS, MK for Mac, FS for file system, dot, let me put XFS, and then def, NVMe, and then P4. Yeah, so I think we have an issue here. So I think something went wrong here. So sector size, logical volume. So I think the disk is not that much. Since I have a smaller space, So in this case, let me just get rid of that partition, and then RM4, and then parted, and then quit. So clear. So if I come back to this part, okay, print, yeah. So yeah, remaining with the 3. So if you have enough space, when it comes to partitioning, then it could be very important for you to also assign the file system or attach a file system. And then of course, after attaching the file system, then you can mount. And mounting means what? You're trying to make that disk to be available for use or be available for use. So to mount, you can just use the word mount, def NVMe. And so if it is P4, you have to do that and then specify where to mount. So you are actually mounting this to a root directory called /mnt. So you have to specify that particular partition. Afterward, after attaching the file system. So by so doing, by having this type of mounting, mount def NVMe NP4 and then /mnt. By so doing this is actually manually mounting it. It's all about mounting it manually. But how do we mount it persistently? So you can mount it manually or mount it temporarily, or you can also mount it persistently or permanently. So if you want to mount it, we have a specific configuration file, which is etc fstab. So if I get probably to fetch the contents of this is where we need to manually do what? Mount. This is where we need to manually mount. And you have to specify what? The block name, and then you have to specify the file system and the rest. So it's actually an editable what? Editable file. So if you want to edit it, you can just use VI, and of course it will be editable. So you will add what? You will add the block here. Now the question is, where do I get that block? So if I come and say BLKID, you can see that we have all these blocks. For example, we have the def NVMe0N1. This is what? This is, of course, if we go to the second partition, you'll find that we have the block ID here. The same thing happens to partition 2, we have the block ID here. The same thing happens to block 3, we have the ID. And this is same as, so if I cut /etc fstab, you can see it's the same what? The same block IDs. So that is if you want to mount it persistently. if you want to mount it persistently. So those are just but concepts relating to partitions. And for that case, you can now move to, as long as you have enough space within your system, you can have it as a way of doing what? As a way of disk partitioning. Whether you have for MBR or you are working for the GPT, it's actually the same piece. Is then the same node. So the only important thing is that you need to understand, how do I create a partition? How do I assign a file system to a partition? And again, how do I mount a partition, whether temporarily or persistently or permanent? So that brings us to the end of this particular topic on managing basic storage structures. So thank you and see you in the next tutorial.